So again, we said that most of the destination-based mechanisms could not accurately detect and respond to the attack before it reached the victims, and it actually wastes the number of the resources on the parts of the victim. Hence, we can actually find out that these are not effective and not capable of detecting and responding to the DDoS attack traffic properly. So therefore, the network-based DDoS defense mechanisms have been introduced to address this problem once again. So here in case of a network-based defense, we are talking about the section that where would these defense be introduced. So these network-based defense mechanisms are actually deployed inside the networks. So you have your networks present, and we had this case now where this was for your destination and this one was for your source. So in case of a network, we found out that we'll be deploying it within the medium. So here, these mechanisms are actually deployed inside the network. So this is your inside the networks. And where could be deployed? We had found out that there are routers present inside the networks. So these routers would be the place where the defenses will be introduced. We can say that the network-based defenses are mainly on the routers of the autonomous systems. Okay. Now, the detecting the attack traffic and creating a proper response to stop it at the intermediate network is an important role of this category. Now, when I'm talking about that, the detection and prevention of the traffic would be done at this router end itself. I need to have certain mechanism. So one of the mechanism which is referred as a network based, which comes in the category of network defense, is a route based packet filtering. So by now everybody knows and everybody would be aware of the concept of packet filtering. Okay. Now in case of packet filtering, what happens is that all the incoming and the outgoing packets would be analyzed and filtered depending upon the filtering rule. So one of the packet filtering thing which we discussed was when were talking about ingress and egress filtering. Okay, so this is something which is similar to this. Okay, now in case of a route-based packet filtering, we are actually saying that it extends the concept of ingress filtering. Okay. Now, where is this extended? It is extended to the routers. So we had ingress filtering at the source. That similar concept has been extended to the routers which are there onto your network. Okay. Now, what happens over here is that the traffic on each link, which is, let's say there are multiple links which are established. So each of the traffic or every link's traffic is actually analyzed. How would it be analyzed? That the traffic on each link in this entire network is generally originated from this particular source. So if there is any unexpected source address which appears in the traffic or which appears in the IP packet of any link, then it is assumed that the source address has been spoofed. Okay, when such thing is encountered, what would happen? The packet would be filtered. Now, identifying the IPs, identifying whether the IP is spoofed or not, this can be done. But what if there is a legitimate user himself who is trying to behave as an attacker? Okay, so this means that the proposed mechanism of route-based packet filtering is effective only when the DDoS attack or the DDoS attack is launched by a client who is spoofing the IP, okay, or is done by a malicious user. What if the attack is actually done by a legitimate user and he uses a genuine IP address to launch the attack? Instead of actually spoofing, he can actually cause the victim over here to collapse. Fine. Such cases will not be detected by a route-based packet filtering. So route-based packet filtering focused upon filtering at the router's end, which are there into the network. Routers were filtering it on the basis of IP addresses. Okay. Had there been any IP addresses which has not been utilized for sending the data or is assumed to be a spoofed IP address, your routers would drop the packet. But your routers will not be able to drop those packets which are actually having the IP addresses of valid systems. Fine. So in this case, we can say that this mechanism is ineffective against DDoS attacks if the attackers either use your genuine IP addresses instead of the spoofed ones or spoof with a very carefully chosen IP address which is not ready to be filtered out. Clear? Now, this mechanisms, as I said, that it would be implemented inside the router. Okay. When you are implementing any add-on inside the router, this would incur two important things. One would be your router should have higher storage. Okay. And the other thing is that there would be a higher processing overhead required at the router's end. Fine. Now, both of these factors, which one is the high storage and the processing overhead, which are the resultant of a network-based mechanisms at the router, would make the system ineffective. Ineffective in what case? That there would be delay introduced in the traffic. There would be higher clock cycles required. There would be extra CPU units required at the router's end. Okay, now both of these overheads in the storage and in the processing would worsen if each router does this thing. What is the router doing? Your router is monitoring every packet which is flowing into the network. Okay, so let's say there are multiple routers, three routers over here. So पहला router पे जब वो packet आया, depending upon what filtering rules does this router have, it would add an extra overhead into that packet. Then again, the packet comes on to the next router. Similar thing would happen at this end as well. So what is happening over here? There is redundancy in processing being generated. Okay, so here these overheads would actually be worsened if each router does redundant detection and response through the path to the destination. Okay, so there would be a significant amount of overhead generated on every packet which flows into the link from the source to the destination. Now, what should be done in order to eradicate such a system or eradicate such problem? So basically, the focus is majorly done on the storage section. Okay, so for storage, what is being done is that there would be less amount of CPU cycles required for detection and response. So it is majorly focusing upon developing certain technology or certain system which focuses upon storage, as well as when we are talking about storage, it would also reduce the number of CPU cycles which is required in processing every packet which arrives at the routers. Okay, so I'll give you an example of a particular technology which is based upon this. There's a concept named as Bloom filter. Okay, so this is used in multiple applications. One of the application in which it can be used is finding out routes, or it is actually used in routing of the packets. So you would have heard the routing protocols like ZRP, that is zone-based routing. So there, multiple zones are created based upon the heat or heat generated by the nodes. So uh, based upon the heat generated by the nodes, the what's say the circles or the actual areas within which your nodes are residing change. Okay, so this ZRP is basically an ad hoc network protocol. So here your nodes will be moving depending upon the energy associated to them, and these can actually be used in establishing the routes from the source node to the sink node. Fine. If I want to give one more example for Bloom filters, um, this has the something which is related to searching. So Facebook generally gives you the optimal searching. It is said that it is giving you an optimal searching. How is it giving you an optimal searching? It has something which is similar to Bloom filters. So if I search somebody's name into my profile, I would be listed on with the n number of users who are having those names. Now, which user comes first? That would be the optimality concept. So when you're getting any user's name as first name, that particular user would be very distant to your location, or very near to your location. So into your entire network, if there is somebody else as well who has searched that name and found out, then only that particular name would be displayed at the first index. Clear? So depending upon the search of a particular keyword and depending upon the location, how many times is that particular word being searched and how near is your location, uh, based upon these two factors, the engine is optimized. So similar thing is done in case of Bloom filters which are implemented in routers. Okay, you do not need to go into very detail of Bloom filters because it is a very research aspect. If you want, you can study it from your end. Now, when you're implementing the Bloom filters, you'll require the concept of hashing and you'll require the arrays as well. Okay, so there would be possibly 2 to 3 arrays which stores the information and one array which stores the priority of a particular value which needs to be searched. I'm only giving you a vague idea that what is the actual concept of Bloom filters. So depending upon the application, your Bloom filters implementation changes. So one of the proper way of reducing the amount of storage and consumption of the CPU cycles for detection and response at the routers, you can use Bloom filters. Okay, the other thing which can be used is packet sampling. So this approach I had not discussed previously. If you want, you can study it. But obviously, these are the things which need not to be discussed much in the detail. I'm only giving you the overview that what are these and where are these used. So when you are having these two approaches like Bloom filters and packet sampling, it is not very sufficient that, or these approaches are not very sufficient because routers are still employed in doing the redundant jobs. Okay, so yes, it would reduce the amount of detection and the response between the routers, but it would not have a substantial amount of reduction. Okay, so due to this, there are different communication protocols which have been proposed to coordinate various attack detection and the response in the routers. But still, these are referred as those systems which would compromise routers. possibly because of the overhead which is generated at the router end and in turn compromising the victim. Okay, so we can say that the network based defenses which have been proposed till now are not very effective and efficient due to the large overhead on the network communication. Also, there would be obviously since we are saying that there is a DDoS attack which has occurred into the system, there is obviously lack of bandwidth. And still, when you are employing routers and the defenses at the router, the bandwidth would still be compromised. Okay, and there are higher chances that your network-based defense mechanisms would fail. So the other concept we tried to have, which was there, I'll take the advantage of all of the proposed systems or all of the proposed defenses, and some sections of each of these defenses would be used to try to prevent my victim or try to prevent my network from completely collapsing. Yes, there are chances that the systems would collapse, but the priority of collapsing or the scalability of the system would actually not be compromised. So this would have the concept of hybrid mechanism, or I can talk of say it as a distributed defense mechanism. Okay. Now these distributed mechanisms, which are different from the one which were the previous one, that was they were the centralized, and this one is a distributed. Okay, so these hybrid defense mechanisms are actually deployed at multiple locations. So what are these multiple locations? These could be source, these could be destinations, or these can be at the intermediate network. And these all of these locations or the mechanism deployed at all of these locations usually work in cooperation. Okay, and for instance, the detection can be done at the victim side. So I'm talking about detection of the attack. I'll do it at the victim side. Okay, and for instance, I want the response to be handled. I would handle the response, which can be initiated and distributed to other nodes by the victim. So I'll employ it at the source. I can do prevention at any other end. Let's say I'll do it at the source or I do it at the network. So you can have multiple combinations. It is not very standard that every time detection would be done at the victim. We'll try to find out that case in which if I do the detection at the victim side, it would be much more effective and it would turn out to be positive. Fine. So one of the approach, I'll only discuss one approach in this. We need not discuss all the approaches. So one of the primary approach which is there is referred as a hybrid packet marking and throttling mechanism. So I guess everybody knows what is packet marking. Okay. And when we were talking about packet marking, we were marking the uh, every packet which flows onto the from the particular router with the specific IDs. These were the router's unique IDs. Okay, and so we'll be doing filtering on those packets or filtering the packets which are marked according to specific routers. Okay, so we can say that the attack or see or sorry we can say that the Am I audible?
Ma'am, your voice is not coming.
Okay, there was some internet issue over here. Is it coming now?
Yes, ma'am.
Yes, ma'am.
Okay. Okay, okay. Which one? From where should I repeat? Please
Ma'am,
repeat.
hybrid one.
Hybrid. Okay, I have not yet discussed it. I'll discuss it now. So for um, fine, this section, right?
Yes, ma'am.
Okay. So for hybrid, what did I say? Is when we were talking about individual approaches, source, destination, and network, we had a centralized system. So both the detection and the prevention were done at each end. Each end as in at individual end. So अगर हम नेटवर्क बेस्ड डिफेंस की बात करते थे तो हमने राउटर पर ही डिटेक्शन भी कर रहे थे कि जो इनकमिंग पैकेट है whether it is a spoofed IP packet or whether it's a genuine IP packet. And there as well, we were preventing it. How were we preventing it? We were preventing the outflow of that packet by applying a filter. Okay, so it was a very centralized approach. Had there been a case that the router got affected due to some of the failures, in that case, the entire system would neither do detection nor it would do prevention. Clear? So here now when we're talking about hybrid, we have distributed the process of detection, prevention, and a particular response which would be created for that particular attack. Okay, so you can have a system where your detection is normally done at the victim, your response is generated at the source, or your prevention is done at the source. Now, all of these three things need not be done on these three levels only. You can employ anything. You can employ detection at network, you can employ prevention at the destination. So, whenever you are employing these detection, prevention, and response techniques, you would have them in conjunction. So ऐसा नहीं होगा कि अगर डिटेक्शन खत्म हो गया आपका कोई सिस्टम कॉम्प्रोमाइज हुआ your prevention and response will not work. Your prevention and response will work depending upon whatever rules have been added. Okay, so one of the example which is there into the literature which talks about hybrid detection is referred as hybrid packet marking and throttling mechanism. So previously when we discussed about packet marking, we said that whatever packets flow through the router, all of those packets will be marked with the unique ID of the router. Okay, and there was a traceback mechanism added which lets you identify what is the actual source who had originated that particular packet. So that traceback mechanism was also introduced at the router only. We said that the traceback is the functionality, which is the functionality of a router. So saying again that both the detection and prevention is done at the router only. And let's say if the router fails, then the entire system would be compromised. So here, in case of a hybrid packet throttling mechanism, usually we place the attack detection modules near the victims. So you had the originator and then you had the victim, and let's say there's a router present between. Okay, so what I'm saying is inside or near the victim, I'll place the attack detection. Pen is not working. Fine, my pen is not working. I'll verbally say it. So here my attack detection will happen at the victim side. Okay. Now, when I'm saying that the attack detection would happen at the victim side, where would the filtering happen? Which side would take filtering? I'll place the filtering of the packets near to my sources. So here I'll have system which is talking about filtering. Clear? So this is the section victim side or the router which is near to the victim will identify the attack. The other side, which is the source side, will try to prevent the attack by dropping the packets. Okay. Now, there are many mechanisms where the victims which are under the attack would actually have a router installed at them. Okay, so those routers which are near to the victim would be used when I am backtracking my traffic. So in that case, those routers will be referred as the upstream routers. Clear? Now, when I'm talking about these upstream routers or those victims which are actually under the attack and have the, what should I say, the upstream routers itself installed, then these upstream routers would be used once the attack detection has been done. Okay. Now, what would these upstream routers be doing? These routers would be notifying the above level routers or those routers which are above it to actually limit the traffic. Now, limiting the traffic would mean that I'm trying to limit the traffic or limit the rate at which the packets which are being forwarded from the originator to the victim. Clear? Now, I'll give you a scenario. Here, the router which is installed near the victim. Okay. So once the victim has identified that there is an attack, your victim would try to notify it to the nearest router and say that the attack has occurred. Okay. Or whatever the incoming traffic is coming at the victim's end is actually from the attacker. What would be the role of the router which is near to here victim is he would try to communicate with the upstream routers and say them to limit the traffic. Okay, so this entire information would be communicated until the router which is near to the originator. Okay, when the router which is near to the originator receives the request, how would he be limiting this? Either he would be limiting by uh, keeping track of the information which was there. So we had one concept which was D word where we were limiting the traffic. Okay, that D word normally was limiting the traffic by dropping the packets. So same concept would be applied over here. Yes, the router present near the originator would limit the traffic by employing the filtering rules. Okay. Now, when these filtering rules are applied, these filtering rules will be applied to only the legitimate user or will they be applied to all of the traffic? These will be applied to all of the traffic. Okay. So, because the originator is not aware of which router or which particular source is sending the spurious packets. Clear? So here in this mechanism or in any hybrid mechanism, your victim would install or victims which are under the attack would install a router at the upstream routers level and ask the above routers to limit the forwarding packets. Okay. All those packets which are actually dedicated to this particular victim only. Clear? Now, when I'm talking about limiting these packets, the mechanisms which can be used can either be an ingress or egress, or it can be deword or anything else which is actually referred as a source based defense. Clear? Any doubt? Any doubt? Sure. Do you want one more defense to be discussed for hybrid, or is it too much?
Yeah, we can discuss it.
We can discuss it. Okay. So we'll discuss one more concept. So there is one more thing which is DEFCON. Okay. So this DEFCON is referred as Defensive Cooperative Overlay Mesh. Okay. I'll only give you the basic idea what is involved. You can go through the document in detail. Okay. Now in this DEFCON, every node is given certain important aspect. There are some messages which are flowing into the network which are identifying and creating a defense for those attacks. Okay. One of the message which is there is the attack alerts. Okay. Now there are attack alerts generated into this entire network. Where are these attack alerts generated and who is generating? There are certain nodes which are referred as attack alert generators. Okay. Now we said that the attack detection is normally done at the victim side. Okay. So whenever any victim identifies that there is a possible traffic which is a spurious traffic and it needs to backtrack the network or it needs to backtrack the uplink, what would the victim do is he would send a message to certain nodes who are referred as attack alert generators. Okay, it would send a message that there is a possible traffic into the network which is a spurious traffic, and it would send attack alerts or it would notify those nodes to generate attack alerts. Okay, these nodes on reception of the message would generate those alerts to the rest of the network. Clear? Once all of the nodes or all of the systems users who are present into the network receive this alert, the next message which would be issued into the system would be a rate limit request. Okay, so this rate limit request would be sent in upstream, which is actually a possible defense for those attack alerts. Fine. Next message which would be circulated is resource requests. Okay. So this resource request tells that each node is issuing this resource request message and each node issues should be sent to its downstream neighbors. Clear? So whenever any resource is required by a particular node, it would only communicate with the nearest or node, or it would only communicate with the router or node which is next to it. Okay. Finally, there is a concept which is traffic classification. Okay, so there are certain nodes which are referred as traffic classification nodes, and these nodes actually communicate with their downstream neighbors to ensure that the entire amount of traffic, which is comprising of the legitimate traffic and the non-legitimate traffic, should not be dropped. So the major portion which is dropped should be a legitimate, non-legitimate users traffic, and a lesser portion which needs to be filtered out is therefore a legitimate traffic. Okay, so these traffic classification nodes only focus upon the factor that it would communicate to the its downstream neighbors that they should only filter out non-legitimate users traffic. Clear?
मैम यहाँ पे जो अलर्ट अटैक अलर्ट नोट्स एंड ट्रैफिक क्लासिफिकेशन नोट्स हैं ये राउटर्स ही होंगे?
हाँ, ये राउटर्स हो सकते हैं, कोई
तो
भी हो
उनका
सकते
फिर
हैं।
कंप्यूटेशनल ओवरहेड बढ़ नहीं जाएगा जो हमें पहले दिक्कत आ रही थी?
तो हाँ, कंप्यूटेशनल ओवरहेड बढ़ेगा, इसलिए हम क्या करते हैं कि हम कुछ ही नोड्स ऐसे कंसिडर करेंगे, कुछ ही राउटर्स ऐसे करेंगे जो अटैक अलर्ट्स जनरेट कर सकते हैं। हम
ओके मैम।
किसी नॉर्मल, जो हमारा नॉर्मल सिस्टम नोड भी होगा, उसको भी हम अटैक अलर्ट जनरेट करने के लिए बोल सकते हैं, क्योंकि हम कम्युनिकेशन तो सारे एंड से करेंगे ना।
ओके मैम।
Ma'am, there is one doubt. The traffic classification which we are doing
हम्म,
for like unlegitimate users. So
हम्म।
तो unlegitimate का हम लोग पोर्शन कम करना चाहते हैं, legitimate का बढ़ाना चाहते हैं. So like detection वगैरह कैसे होगा कि like ये जो डेटा है या ये जो ट्रैफिक है वो अनलेजिटिमेट यूजर से ही आ रहा है. So we have to go for upstream routers to confirm that.
यस।
Okay.
अभी तक हम ये बिलीव कर रहे थे कि सर्वर एंड पर जब विक्टिम ने क्लासिफाई किया, वी आर गिविंग द आईपी एड्रेसेस एज अ मेजर सेक्शन, दैट कि हम आईपी एड्रेसेस के बेसिस पर क्लासिफाई कर रहे हैं कि कोई यूजर अटैकर है या फिर नॉर्मल यूजर है। ओके, अगर हमें दूसरे एस्पेक्ट्स कंसिडर करने हैं तो हम रेट ऑफ फ्लो ऑफ पैकेट्स कंसिडर कर सकते हैं, या फिर विक्टिम एंड पर अगर कोई एक पर्टिकुलर रिसोर्स बार बार यूटिलाइज हो रहा है, बार बार उसी के लिए रिक्वेस्ट आ रही है, तो हम ये कह सकते हैं कि पॉसिबली ये ट्रैफिक जो आ रहा है फ्रॉम अ पर्टिकुलर सोर्स इज एन इंट्रूडर्स traffic. So with these assumptions, we try to backtrack it, or we try to go in the upstream links.
Okay.
Any other doubt? Okay, so with this, I'll complete the hybrid. I'll no more discuss the DDoS defenses. Okay, so you already have the paper with you. For today's class, I discussed the section A1.3 and A1.3.A. You can write it so that I do not need to send it once again. Okay, the section is A1.3 and A1.3.A. Okay, on that very page itself, you have one paragraph above A1.4, which talks about the Bloom filters, and also it talks about what are the overheads involved in the network-based defenses. So go through it, you'll get an idea of what are the drawbacks. Then you have distributed defenses, which is part of A1.4, and A1.4.A, which talks about hybrid packet marking. Okay, so hybrid packet marking has multiple other approaches as well. Only the idea which is behind the hybrid packet marking has been told to you. So for the specific defense, you can read defcom, which is, I guess, is A.1.4b. Okay. Um, so tomorrow you have a minor on DOS and DDoS. It also includes buffer overflow, some basic concepts of buffer overflow. Okay, so I'll send you, it would be an objective quiz tomorrow. It would be an objective examination. So you'll have a specific time limit, probably 20 minutes or 25 minutes. You'll have to submit it within that time limit only. Beyond that, I'll only consider 2 to 3 minutes.
Okay,
So
ma'am.
please be very sure that you have a proper internet connection so that you do not get delayed in submitting it. And you'll only have to submit it once. You should not submit it multiple times and only consider once.
That
जो
will be
आप,
on Google quiz, no?
हाँ गूगल फॉर्म से ही होगा.
Okay.
ठीक है, मल्टीपल रिस्पॉन्सेज मत सबमिट कीजिएगा क्योंकि जो आपका पहला रिस्पॉन्स होगा उसी को मैं कंसिडर करूंगी. ओके,
Okay, ma'am.
ओके
फाइन.
मैम.
Ma'am, can you share the contact of Himanshu sir?
हिमांशु का
मैम जो जिन्होंने आज पीडीएफ भेजी थी.
क्या हुआ, कुछ में कुछ इश्यूज हैं क्या?
इसमें मैं थोड़ा मैम डिले वाले में सर से पूछना था कुछ.
ओके, तुम उसको कर लेना, मैं कांटेक्ट तुमको उसी ग्रुप पे डाल दूंगी.
यस मैम. या तो सर को ऐड कर दीजिए मैम उसी
हाँ,
ग्रुप
मैं
पे.
ऐड कर देती हूँ उसको. आप लोग जो भी डाउट्स हो, इसलिए मैंने बोला था कि आप लोग अपने डाउट्स उस पर अपलोड कर दीजिए.
ओके मैम.
मैम वो सर भेज रहे हैं, डाउट्स था मेरे को तो सर ने वहां से वापस भेजा था रिस्पांस, मेरे को क्लियर हो गया.
ओके देन, ठीक है.